Welcome to a lesson with Dr. Pal. As promised in the last video, we're going to again look at the multiplication of these series and look at how we can do it in another way. First off, notice these are both geometric. We can sum up each one of these, like this one is an infinite sum with the 1 minus x, since we're multiplying by x every time, of course within its radius or its interval of convergence, where it's defined, it's equal to this. And similarly over here, this would be 1 over 1 minus 2x, since we're multiplying by 2x each time to go from term to term. So what we can do is we can think, okay, this is like 1 over 1 minus x times 1 minus 2x. Let's use a partial fraction decomposition. So we can think 1 minus x and 1 minus 2x, and we can get something here and add them. Okay, so what goes here, we can use the cover-up method. So we think, well, 1 would make this 0. So let's cover this up and put 1 into the other part, and we get 1 over 1 minus 2, which is negative 1. Over here, let's see what we get. So 1/2 right here would make this 0. So we put 1/2 in the other part, and we get 1 over 1 minus 1/2, which is 1 over 1/2, which is just 2. So we get 2 right there. Okay, so we have this plus this. Now, this right here is a so this right here is a power series. You can think of it as a geometric. You just multiply -1 to something, and here we multiply 2 to this. Let's see what happens. So this is like negative x to the j. J goes from 0 to infinity, because it's just, we factor a negative out of just 1 over 1 minus x. And then this is just 2 times this series, which we already had going on here. Now notice how we get this very, very nicely here. In fact, since we're adding, we could just make these ends, because if we're adding, we just want to combine like terms, and we like things to look the same. Okay, so we're just going to add series across. Now, how do you add series? Well, the same way as you add to any two polynomials, you just add like terms or like powers. So, okay, so in general, if we index this with the same index, then we're just thinking nx to the n over here. So this 2nx to the n over here will add with this xn over here. Well, after we multiply it by this 2, right? So maybe we should distribute that in. So distribute that in, and that effect of distributing it in is just to add 1 to that exponent. Now, and we can distribute this negative in. So then we just have negative x to the n. So the like terms at x to the n are just negative x to the n and 2n plus 1 times x to the n. So quite literally, we have this by adding. Okay, so we add like terms, and we have these that we're adding up at each end. And notice that if we factor out x to the n, or just add these two parts, we have -1 plus 2n plus 1 is the coefficient of x to the n, which is exactly what we saw in the last video. Essentially, let's just kind of write this out at the end. So we have n equals 0 to infinity, and then we have 2 to the n plus 1 minus 1, all multiplied by x to the n. So we saw how we multiplied these series by interpreting them as geometric series, and then and writing a formula for those using partial fraction decomposition, so that we could now add series. So this adding of series was fairly straightforward, and we got the pattern very quickly, the formula very quickly, and we ended up getting the sum, or the summation, the series for the result of the multiplication. Thanks for watching.